Hey everyone, welcome back to the channel where all your maths questions get answered. If you're here, you probably want some quick and effective tips for tackling maths questions, whether it's for homework, exams, or just for fun. And let's face it, maths can be tricky, but it doesn't have to be. Let's dive straight into today's question. Jackson is trying to find the density in grams per centimetres cubed of a block of wood. So the first thing we can take away from this question is the fact that we have got density and we need to try and find something in terms of the density. So we're trying to calculate the actual value using bounds, okay? Because we have got potential values, because they are rounded to the nearest millimetre and the nearest 5 grams, we need to be actually finding the upper bound and the lower bound of the density. So if we start off by understanding what the upper and the lower bound are, upper and lower. So our formula for each of the upper and the lower bounds are going to be the mass, so in grams, divided by the volume. And we can always actually use the units within the question to help us identify that. We've got grams divided by centimetres cubed, so we're going to be doing the mass divided by the volume. Now, within this question, we need to identify the upper and the lower bound, and then work out a suitable degree of accuracy from that. So, in order to find the upper bound, we first need to identify what the upper bound is in terms of our mass divided by volume. So in order to make the number as big as possible for the upper bound, we want to have the largest possible number on the numerator and the smallest possible number on our denominator. This will give us the upper bound of a value. So we need the largest possible mass. Now the mass is 1,970 to the nearest 5 grams. So this can be rounded up to 1,972.5. Okay, so rounded to the nearest 5, this means the upper bound is 1972.5. Now, for the upper bound for the density means we need the lower bound for the volume, as we stated here above. So the lower bound for our volume is going to be calculating the lower bound of all of these and timesing them together because we have a cuboid. So we need to take into consideration the 13.2 to the nearest millimetre. So this will go to 13. We wanted the lower bound, so this is going to be 1.5 because this is in centimetres at the moment. 13.2, that's 13 centimetres and 2 millimetres at the end, so we can go half either side of the millimetre. So this is half a millimetre taken away, times by our 16.0, which if we round it down is going to go to 15.95, times by our 21.7, which will go down to 21.65. So this here is our lower bound for the volume on the denominator and the upper bound for the mass on the numerator to give our upper bound for the density. So we'll just grab a calculator, plug these numbers in. 1972.5 divided by 13.15 times by 15.95 times 21.65. Now always check your units as well. We need this in terms of centimetres cubed. It is currently in centimetres, so when we do the working out, it will remain in centimetres cubed. So our upper bound here is equal to 0.43438. Okay, I'm just going to pop that here as well. 0.43438. Now, we're going to be using that number to work out the actual value afterwards. Now, it has got a few more decimal places, and I'll just pop everything on the calculator on the screen, just so we can see how our working should be laid out. But now we need to find the lower bound. Okay, so I'm going to do the lower bound here as well. But for the lower bound, we do not want the same numerator and denominator. We need to change these so that they match for the lower bound for the density. So for the lower bound, we need the smallest mass divided by the largest volume, because we have a smaller number divided by a bigger number, that is going to give us a smaller number, which means our lower bound here, we're going to round our mass up, our mass down, 19, that's why I always write it down just to make sure. So this is going to be 1967.5, because we're going 2.5 grams below, so half of whatever it is rounded to is what your bound can be. And then for the volume to the nearest millimeter, we're rounding each of these up, so this is going to be 13.25 times by 16.05 times by 21.75, and this is all still under one fraction. So we can grab our calculator again and substitute these numbers in to see what we end up with. Now I have got, let's see, 0.05 times 21.75. Make sure you're putting in all the numbers carefully on your calculator. Do not make a mistake at the easiest step, putting numbers in a calculator, as you have done all the hard work to get to that stage. So let's just pop all of these on for 6. Right, so we have got 0.425367756 for the lower bound. So as we can see, we have got our two numbers here. So I'm going to write out just the first few terms over here, 434 and 0.425. Now these all have other values, but they do not round to give the same thing. So when we are calculating this type of question to work out the density, and by considering bounds, we need to see what these two things are going to round to that is the same. So both of these numbers would round to many different things depending on where we cut off the point to round at. So if we rounded both of these two as they are currently, they would round to 0.434, as in if we had other values here, because the next term would be a 3, and for this one 0.425, because the next term would be a 3 as well. So both of those two round to something, but they round to something different. So we know we cannot have them rounding to 3 decimal places here. We need to see if it can get round any further so that they go to the same thing. So if we try and go to 2 decimal places, we can see that the top one rounds to 0.43, because the 4 means we round down to the 3 for this one here. And then for the second one, 0.425, the 5 means we round upwards, so that would also go to 0.43. So they both round to the same number here as 0.43 after 2 decimal places. So our answer for the density would be 0.43 grams per centimetre cubed, rounded to 2 decimal places. I hope you enjoyed the video. Thanks for watching, and don't forget to comment your questions down below. See you in the next one.